Hey guys, this is Miss Grisenda, and we're looking today at surface area and volume. So if you would go ahead and get your paper set up, you can put this title at the top and make sure you have your name, date, and period over on the right-hand side. And I'm going to highlight the title. Okay, and then make that horizontal line right with the top line of your loose leaf. And then let's set up our paper for Cornell Notes. Make sure that you have a small left-hand column. You're going to use this part to the left of the pink or the red line and about an inch or so on the right-hand side of that. So just fold your paper to make a small left-hand column, and we need a larger right-hand column. We have a couple of vocabulary words, and I like to put the vocabulary words in quotation marks. That lets you know that those are words that you would find highlighted in your textbook, and you would find the definitions in your glossary. So surface area is the sum of the areas of all the faces of a 3D figure, and it's measured in square units. Area is measured in square units, and surface area is just the area of all of the surfaces. So we're talking just about the outside of the figure. Volume is the amount of space that a 3D figure occupies, and that's measured in cubic units because this is a three-dimensional measurement. We've got length, width, and height, and we're measuring how much space the object takes up. I also want you to put the key over here. You could print out another copy of the reference sheet and cut the key off and kind of paste it into your notes. And I'm going to go through with you where to get that reference sheet again in a minute. We're going to use almost all of these today. So it's a good idea to have that right there in your notes. It's easier than having to go back and forth to a reference sheet. And that way your notes will make more sense to you later. Instead of just having all those letters, you'll actually know what they mean. And then let's set up two columns here. We're going to have a column where we're going to be working on volume and another column where we're working on surface area. So you can highlight your notes if you like. You don't have to, but I find it's easier to kind of pull out all the information and see things more clearly. I like to highlight my vocabulary words in yellow because that's the color they usually use in the textbook, so that kind of helps me to see that those are some terms that I need to know. Okay, now we're going to go all the way down to the bottom of the page and set up the spot for the summary. And actually, I'm going to give you the summary right now. So make sure that you can fit that at the bottom of your page, and then you're going to add this horizontal line right above it. If you run out of room up here to show your work, you can just carry that work onto the back. So I'm going to highlight these vocabulary words again. And again, I like to use yellow for my vocab words, but you can do that differently if you like. Surface area formulas can help you calculate the amount of paint you need. Think about it, you're only painting the surface. You're not going to fill something with paint. So if we're painting something, we just want to know how much area on the surface we have, or how much material is needed to make a hollow object. If I'm making like for example, a shoebox, I only need enough material to cover the outside. I don't have to fill the whole thing. So that would be talking about surface area. Volume formulas can be used to calculate how much an object holds. Another word for that is capacity, or how much material is needed to make a solid object. If you're going to make something that is completely filled in, then you would have to have material for all of that. So that's the difference between surface area and volume. Sometimes they'll specifically tell you surface area or volume. That makes it a lot easier. Sometimes you have to kind of figure out, what do I need to find here? Am I looking for the surface area or am I looking for the volume? So this summary can give you a couple more clues. All right, now that we have that done, let's go back up to the top. And before we move on any further, I want to make sure that we have a reference sheet. So if you have one in your binder, which you should, go ahead and take that out of your binder and keep it on the desk next to you so that you can refer to that throughout this lesson. If you don't have one in your binder, here's how you can get one. If you go to www.bigideasmath.com, and we'll do that now, and then remember you click on Students, click here and change it to Florida, and then click Go, choose your book, and right over here on the left-hand side is your FCAT 2.0 reference sheet. So you can just go ahead and print that out. It is 2 pages, so if your printer does back-to-back, that's great. Or you could just have 2 separate pages. You could put it in a sheet protector. That would be a fabulous idea. Don't click here. This is the reference sheet from your textbook. This is not really the one we want. They have the formulas will work, but they're not the same ones that you're going to have available to you on the FCAT and on my tests. So make sure that this is the reference sheet that you're printing and that you're using today. Okay, so let's get started. I'm just going to scroll this up here. And here's our first shape. And before you even draw that, let's take a look at what that is. So let me pull up my copy of the reference sheet. Now, they have these great little pictures on your reference sheet. So if you are confused and you can't remember which kind of shape that is and what the name of it is, you can just look at the little pictures. And it looks the most like this one. It is, in fact, a rectangular prism. So I'm going to come back in over here and let's label that. So this is, let me change the size of my pen here. Hang on a second. Okay, that's better. So let's label this. This is a rectangular prism. Sometimes the Mobi does not like to cooperate with me. Okay. And we can see that looking at our reference sheet, we need the volume formula. So V equals BWH. Let's write that down. Notice that it was a lowercase b, and you have both a lowercase and an uppercase b on your key. So we're going to have to be really careful about which one we're using. They are not interchangeable. They mean 2 different things. So let's see if I can get a little bit better handwriting here. B, W, H. Okay. Now, if we look at the key, B is the base, W is the width, and H is the height. And we have 3 measurements on this rectangular prism. Technically, it really doesn't matter which one's which. If you think about it, you could turn that rectangular prism on its side or upside down, and then the base width and height would technically be different. So it really doesn't matter. We're just going to go ahead and label these so that we can keep everything straight. I'm going to call that one the base, that one the width, and we'll call this one the height. So remember, it doesn't really matter which one's which as long as you are consistent throughout the problem. Okay, so the base is 12. And remember, BWH means it's B times W times H. So I like to use parentheses. I think the multiplication dot sometimes can get confusing. It tends to look like a decimal point sometimes, or just like it's sloppy. So you can use the parentheses if you want. You can use the multiplication dot. Technically, you could use a little tiny X multiplication symbol, but I don't like those. They sort of look like variables now. So all right, the next one we need is W, which is the width, and that's also 12. And then H is the height, which is 14. So this is a pretty simple problem. You've been doing these for a few years. Now all you have to do is take your calculator and do 12 times 12 times 14. and it is 2016. So 2016. And then remember that volume is measured in cubic units. The units here are feet, so it's going to be feet cubed. This is 12 feet, this was 12 feet, and this was 14 feet. So if we do feet times feet times feet, that's where we get the feet cubed. Okay, and then over here we're going to solve for the surface area, and we usually use SA, and that's even up there on your key. SA equals surface area. So we need to go and look at the reference sheet. We need the surface area formula for a rectangular prism, and that would be this one right here. Now notice that they have two formulas. There's this formula or this one. This formula or this one. The second formula uses the capital letter B, which is the area of the base. So if they gave you the area of the base of the rectangular prism, you would just take that and multiply by the height. They didn't. They gave us the base, the width, and the height. So that's why I chose to use the first formula. So we're going to, for today, we're always going to be using the first formula. We can look at how to use the other ones. If you want some more information, just ask me, or you can look at your key and kind of figure out what's going on there. All right, so for surface area, we need 2BH plus 2BW plus 2HW. So that was 2BW plus, sorry, they have 2BH. It wouldn't really matter, but I'll go ahead and change it so it's exactly the same. 2BH plus 2BW BH plus 2BW plus 2HW. Now, it wouldn't have really mattered if I had left those switched. Remember that addition is commutative, so it doesn't really matter what order I add them in. What's important is that you have the B being used twice, the H is being used twice, and the W is being used twice. That's kind of a way to double check and make sure you wrote it down correctly. Okay, now 2BH, remember, means 2 times B times H. So I'm going to do 2 times B, which I have as 12, times H, which is 14, plus 2BW. So I have 2. B is 12. W is 12 plus 2 H, which is 14, W, which is 12. So you can see I have 14 twice, and then I have 12 4 times because it's the base and the width. So that all looks good. And then all we have to do is calculate. So I have 2 times 12 times 14, and it equals 336 plus 2 times 12 times 12. Hoping you can do that one in your head. 12 times 12 you should know as a basic fact. That's 144. And then times 2, it should be 288, which it is. And then if you notice over here, we're doing 2 times 14 times 12, which is going to be the same as 2 times 12 times 14, because multiplication is commutative. So I know that that is going to be 336, just like the first part. And then all we have to do is add them all up. because of course we have to follow the order of operations. We had to do all the multiplication first, and then we're going to do the adding last. So I've already got 288 there, plus 336, whoops, 336 plus, oh, that did it again, didn't it? Okay, let's try again. 336, 336. Very important to make sure that you're being really careful when you're doing all your work. Okay, clear. Let's start all over. 336 plus 288. Doing it to me again. Plus 336. Okay. There we go. 960. So make sure you're keeping an eye on your calculator and that you're not hitting the button too many times. And that seems like a reasonable answer. About 300 plus about 300 plus about 300 should be about 900. So that looks good. And our units were feet. And it's area, so it's feet squared. The reason is because here we have 2 times b times h. Well, when you do 12 feet times 14 feet, feet times feet is feet squared. So feet squared plus feet squared plus feet squared is going to be feet squared. Or you could just remember area is always in square units. All right, I'm going to do a little highlighting here before I move on to the next one. I'm going to highlight rectangular prism. I'm going to highlight the volume formula here and the surface area formula over here. Okay, and then let's move on to the next example. So leave a space in between. We're going to label this shape right here. And then you can go ahead and draw that in there. They don't have to be fabulous, but they do need to be, you know, semi-decent. You could probably find some pictures online if you really are not good at drawing those. Kind of shrink them down, print them out, you know, something that looks very similar, and then label the measurements that are on there if you really don't feel capable of drawing those yourself. All right, so hopefully you know what this shape is called. If for some reason you didn't, which would be shameful. I'm just kidding. Sometimes we forget stuff. Remember, you can look on your reference sheet. Okay. Let me erase that highlighting from before. It looks very similar to this shape. So it is a cylinder. It's probably what you're used to calling it. It's a right circular cylinder. Right means that the top and the bottom, both of the bases are lined up exactly with each other, that it's not skewed off to one side or the other. Circular just means it has a circular, it has 2 circular bases. You could have 2 ovals, and then it would be sort of an oval shape. So they're just being very specific with you. So these are the 2 formulas we're going to need for our cylinder. And like I said, we could use the other formulas. They're just not as common. So we're going to use the first, or the most basic formula today. Okay, so let's label this. This is a cylinder. And the formula for the volume of a cylinder, looking at our reference sheet, is pi r squared h. Pi r squared h. And I'm going to highlight that and highlight the word cylinder. Okay. So this part of the formula probably looks familiar to you. Pi r squared is going to give you the area of the circle, just one of the circles. Okay. And then when we multiply by h, or the height, that's when we get the volume. It's kind of the same thing up here. Base times width will give you the area of the bottom face. And then when we multiply by the height, we get the volume of the whole thing. So remember that pi is 3.14, or at least that's the closest approximation that we're going to use. We couldn't use the actual value of pi. It's a never-ending figure. R squared. R is the radius. So if you didn't remember that, it's right up here. R is the radius. And the radius of this circle is 6 feet. They have that labeled there for you. Sometimes they might give you the diameter and tell you that the diameter is 12, and you'd have to kind of chop that in half and know that the radius is half of that. So I'm going to do 6 squared. And then I'm going to multiply by the height, which is 14. Okay, and we really know that 6 squared, remember we have to do our parentheses first. We don't have anything in the parentheses. Well, this is sort of in the parentheses, but we would have to take care of this exponent before we multiply or multiply. Exponents come before multiplying. So I'm going to just bring this down. 6 squared is actually 36, because remember, it's not 6 times 2, it's 6 times itself. So 6 times 6, and then we're going to multiply by 14. So let's see if the calculator wants to be more cooperative with me right now. So we have 3.14 times 36 times 14. I like this calculator because I can see everything I've done and I know I've typed it incorrectly. So we have 1,582.56. 1,582.56. Kind of a cool trick with a calculator. If you're working on the computer and you've got like a text box or somewhere that you need to put in your answer, you can always edit, copy, and then go back to where you're working and paste it. So that could be really handy, and that way we wouldn't have accidentally written the number down wrong or something. So that's kind of cool. Okay, and since we were finding volume, it is going to be measured in cubic units. So we're measuring in feet. So this is feet cubed. Okay, here we took the 6 feet times feet. We kind of squared the feet, so that was feet squared, and then we multiplied by feet again. That's how we end up with feet cubed. And then let's do the surface area. Surface area. Remember to go back to your reference sheet. Surface area formula is 2 pi RH plus 2 pi r squared. It's worth your time to double check and just make sure you're writing that down correctly. So 2 pi r h plus 2 pi r squared. Okay, I'm going to highlight that. Okay, so now we just start multiplying or substituting in the values that we know. So we've got 2 times pi times r times h. So that's going to be 2 times 3.14 times r, which is the radius again. Remember that this is r. Whoops, probably should have labeled that last time. And then this one is h, or the height. So r is 6 and h is 14 plus 2 times pi, which we're using 3.14, times r squared. So that would be 6 squared. Okay, and we've already talked about this. 6 squared is actually 36. So I could save myself a step there. All right, and then we're just going to use our calculators again. And just be really careful, make sure you're calculating accurately. 2 times 3.14 times 6 times 14. 527.52, 27.52 plus, just remember we're going to do all the multiplying first, so I'm going to do all that multiplying, all this multiplying, and then I'll add them together. Double check that I wrote that down correctly. Yes. Okay, so now we do 2 times 3.14. Nope, that didn't work. 14 times 36. 226.08. 226.08. And then we'll just add them together. My calculator already has that on there, so I'm going to leave that on there and just add 527.52. Double check that I typed it in right. Yep. 753.6. So 753.6. And this is in feet. And remember, we're talking about area, so it's feet squared. All right, let's take a look at the next example. If you're running low on room, I'm going to fit the next two examples right here. So if you've got about this much space, you're doing good. The next example is going to take up 3 lines. So make sure you have this line right here that you can leave blank, and then 1, 2, 3 lines. If you have 3 more lines, you've got enough to do the next example. So here's the next one. And hopefully you recognize this as one of those things in Egypt. So you should already know what this is called. This is obviously a pyramid. So this is one that might be a little bit tricky for you to draw. If you start by drawing this kind of the square that's on the bottom of it, and then you pick a point up here and just kind of draw from each corner up to that point, or the apex. That's the apex of the pyramid. This might be, might be something you might want to just find an image online and print it out and glue it or tape it onto your page, because they can be a little bit tricky for kids to draw. But as long as you made the best effort, as long as you can tell what it is and we can look at that as an example later, then I'm sure it's fine. Okay, this line that's on the inside is the height of this pyramid. Okay, and they've shown you that that makes a little right angle with the base, so that you know that that's really the height. It goes from the apex straight down into the base. This is actually a square pyramid because the base is square. It's 12 feet by 12 feet. So that means that's 12 and that's 12. So it has a square, and then it goes up to 1 point. That makes it a square pyramid. If you weren't sure, remember you've got, let me erase these highlights. You've got these little pictures on your reference sheet. Use them. Sometimes you get stressed out when you're taking a test and you forget everything you know. You've got a lot of information here. So this is a right square pyramid. Again, the word right just means that it's lined up straight, that the apex is lined up with the center of the base. You could have a pyramid that was kind of skewed off to one side where the apex would be over here, and it doesn't make a right angle with the base. So this right angle tells you it is a right square pyramid. So we're just going to label that square pyramid. We've got our two formulas. V equals 1/3 BH. And notice this is a capital B. So we're going to have to be looking up here at this capital B is the area of the base. So that's going to make this a little bit trickier. And then we've got some other letters that we haven't seen yet in the surface area formula. We have a capital P, we have this cursive looking L, and we have another capital B. So we're going to have to be careful in using our key on this one to use the correct measurements. So let's label this. This is a square pyramid. these formulas can only be used on a square pyramid. If the base of your pyramid is not a square, if it's a rectangle or an octagon or something else, you would have to use a different formula. So we have volume equals 1/3 capital B H. Let me do a little highlighting here. There's our formula, and that's the name of our figure. Okay, so I'm going to put the 1/3 here, and we're going to talk about that some more in a minute. So it's going to be 1/3 times capital B. Well, capital B, if you look up at the key, capital B is the area of the base. So how do we find the area of the base? If you look at the base is just a square. Right? And a square is just a fancy rectangle. So to find the area of a square or a rectangle, you do length times width, or base times width. So we're going to do 12 times 12. See, that's why I don't like the multiplication dot. It ended up looking like a subtraction sign. Let me go back and use my parentheses. So 12 times 12 means the area of the base in this example is 144. So when we see that capital letter B, we're going to use 144. All right, so area of the base is 144. And then the height is 14. Okay, so now we just are going to calculate. Now, this one gets a little weird. Some of you don't like fractions, and so you want to change that to a decimal. And that's fine, but if you change it to a decimal, 1 divided by 3 is 0.333333333, 3 repeating forever. If you calculate it just using 0.33 or 0.333, it's going to be not quite as accurate as using all of those 3's. So let me show you a couple things here. I'm going to do 144 times 14 first. 144 times, 144 times 14. So it's 2016, but I only want 1/3 of that. So what I could do is just divide it by 3. That's the most accurate answer, 672. And that would be in feet cubed. Let's look at something else here. If I did 1/3 and just said, oh, that's close to 0.33. If I did 0.33 times 144 times 14, notice it doesn't give me 672. It's close, but it's not even very close. So let's try again. What if we use 0.3333? We use 4 3's instead of just 2. Times 144 times 14. Well, now we're closer, but still not quite right. If I were to do 1/3 on my calculator first, and I have all those 3's, and then I do times 144 times 14, now it's giving me the exact answer. This calculator, when I started with 1 divided by 3, even though it shows 0.333333, it knows it's really repeating forever. Let me show you one more thing. If I were to start by putting in, saying, well, I know that it's 0.3333, I'm going to put in as many 3's as my calculator will let me use. And now I'm going to multiply by 144 and then times 14. It's still pretty close. You probably could say that's actually 672 because you knew that 0.33333333 wasn't really accurate, but it's so much better to just divide by 3 like I showed you in the first place. Okay, if you were to put 671.9, you would get this one wrong. The actual answer is 672, so make sure that you're thinking about that. If it's a multiple choice, you probably could get close enough and you wouldn't have a problem. But if it's, a gridded response, then it's definitely going to cause you an issue. All right, surface area. The surface area formula is 1/2 capital P cursive L plus capital B. And I'm going to highlight. All right, so we've got 1/2 times capital P. Well, if you go up and look at the key, capital P is the perimeter of the base. So remember that perimeter means to add all 4 sides. So 12, we're just looking at the base. 12 plus 12 plus 12 plus 12. Don't forget about those 2 back sides. Or just 12 times 4, right? There are 4 sides and they're all 12. So the perimeter of the base is 48. Now, they have not given us L. If you look at the key, L is the slant height. Okay, it shows it right here. L is slant height. Well, the slant height would actually be, I want this one, this one. The slant height is the distance from the apex to the base running along the center of one of the sides. And they did not give us that in this problem. There is a way using some 8th grade math to figure it out, but I'm just going to tell you that it's roughly 15 feet. It's actually a little bit more than 15 feet, but 15 is close enough for our purposes. So the slant height is 15, and then we have to add capital B, which we already figured out over here is 144. So we don't have the issues with 1/2 that we had with 1/3 because 1/2 is actually 0.5. So I can just do 0.5 times 48 times 15 equals 360. And then we have to add on the 144. And to save space, I'm actually going to just put the answer right over here because I want those lines left for my last problem. So 360 plus 144 is 504. The measurement was in feet. And since we're talking about area, we know that it's feet squared. All right, a last problem. We have one more shape. This one hopefully you recognize as well. This is obviously a cone. So I need the volume formula for a cone. And this is a right circular cone because it has a circle as its base. And it is a right circular cone because the point or the apex lines up exactly with the base. And you can see that here with this little right angle. So I need this formula right here. V equals 1/3 pi r squared h. So we're going to have that 1/3 issue again. And then here's our surface area formula. So volume equals 1/3 pi r squared h. So I have 1/3 times pi. Pi is 3.14. R is the radius, so that's 6. So it's going to be 6 squared, which I'm just going to change to a 36 right now because I know I have to do exponents first anyway. And then h is 14. Okay. So again, we're going to want to do everything but the 1/3 first. So I want to do 3.14 times 36 times 14. And then since I have to multiply by 1/3, it's just much easier to divide by 3. That's going to give me the correct answer, 527.52. And this is volume, so it is feet cubed. And I'm going to do a little highlighting here, and then we're going to move on to surface area, and we're almost finished. All right, so surface area is 1/2. And then we've got 2 pi r. Now in the formula, they put this in parentheses, although they're all just being multiplied together. The 1/2 is multiplied by all this stuff, and then it's all multiplied by L, which is that slant height again. And we're going to add capital B. So that's the area of the base. Okay, so I've got 1/2 times 2 times 3.14, which is pi, times r, which is the radius of the circle, so that would be 6, times L, which is the slant height. And again, they did not give us the slant height for this problem, so I'm going to give you an approximate slant height. Slant height would be from the apex down to the base, so it's actually the side of the cone. And they didn't give us measurement for that, so just like the other one up here, it would be roughly 15 feet. 15.23 or something, but 15 feet will work for us for today. Okay, so that slant height is 15. And now here we have to find the area of the base. The area of the base, this base is a circle. So if you weren't sure how to find the area of a circle, it's on your reference sheet. It's up here at the top. Circle is pi r squared. So the area of the base is going to be pi times r squared, which means it is 3.14. Oops, let me do this. Pi r squared. So right down here for capital B, I'm going to do pi 3.14. That's a 4. And then r squared is, the radius is 6, so squared is actually 36. So all we have to do is calculate. I can use 0.5 for 1/2 times 2 times 3.14 times 6 times 15, and that equals 282.6. 282.6. And then I have to add this calculation for the area of the base, which is pi times r squared, which is 36. So it's a 113.04. And then I just add the two together. I've already got that one on there, so I'm just going to add 282.6, 395.64, 395.64, and it's surface area, so it is feet squared. And there you go. Thanks for sticking with me. I know that was kind of a long lesson, and I will see you in class.